Hi, boys and girls. This is Miss Botta recording Chapter 14, Section 1, Electric Charge and Static Electricity. This goes from page 416 in your book over to page 423. So let's get started. All matter is made up of very small particles called atoms. These atoms are made up of protons, electrons, and neutrons. Now, protons have a positive charge, electrons have a negative charge, and neutrons are neutral. Okay, let's go on. You'll have to overlook announcements that you might hear, okay? All right, so this shows below the law of electric charges.
Carson Quick, come to the office. Carson Quick, come to the office.
Which states that same charges repel, opposite charges attract. Now, you can see in the diagrams just above how the two positives move away from each other, the two negatives move away from each other, but the positive and the negative are attracted to each other, okay? The force between these charged objects is simply called the electric force. Now, there are two main factors that decide the size of the electric force, and that's going to be the amount of charge on each object and the distance between the charges. Next, it says define electric field. Well, this is the region around a charged object in which another charged object experiences an electric force. Now, there are three ways, there are three ways to charge an object, and that is friction, conduction, and induction. Now, an important thing that you need to remember when we're talking about these atoms is that atoms can only gain and lose electrons, okay? They don't gain protons, they only gain or lose electrons, but there's still going to be an imbalance between the positive and negative charges. All right, so the three ways to charge an object: friction, conduction, and induction. Friction, you should know what that is. Electrons are wiped from one object to another. An example would when you've gone down a plastic slide, like at a playground or something, and when you get to the bottom, you touch metal and it shocks you. Or you can see they're charging up a balloon by rubbing it on a girl's hair. Or you rub your balloon on a cloth and then take it to the hair and it pulls the hair away from your head. Second, we have conduction. This is electrons moving from one object to another by direct contact. And this is a charged ruler touching a metal table leg, or when you're walking across the carpet in your socks and you touch the doorknob. That would be conduction. Then we have induction. Now this is new. Charges are rearranged without direct contact. So there's no direct contact, but the charges are rearranged. And the example they show you in the book is a balloon next to a metal wall or a pipe, a metal beam, okay? Sometimes induction can take place in lightning, like you see down below, where there doesn't have to be that direct contact. Okay, a device that is used to detect an electric charge is what we call an electroscope. And I'll show you an electroscope, and some of you may even want to make an electroscope if you do the quick lab that is part of your tic-tac-toe projects, okay? Static electricity. We've all experienced this at times, and this is the electric charge at rest produced by friction or induction. Now, when we say something is static, that means it's not moving. All right, moving on to electrical conductors and electrical insulators. Now, this should be a review for you, okay? Electrical conductors can move charges freely. They allow the negative charges to move through it very easily. Examples would be any kind of metal, copper, aluminum, mercury. The opposite of that would be electrical insulators. They do not allow charges to move freely. Some examples of that would be plastic, rubber, glass. You can also include wood and include air. Electric discharge is the release of static electricity stored in a source or the loss of static electricity as charges move off an object. This is when you've walked across the carpet in your socks and touched the doorknob. That was electric discharge. And lightning, when we talk about lightning, will strike the highest point in a charged area because that point provides the shortest path for the charges to reach the ground. Now, in your book, they show you a cool picture of the Statue of Liberty, the Empire State Building being struck by lightning. Well, there's a lightning rod there. All tall buildings will have lightning rods, so that if that is the tallest object in an area and lightning hits it, the electricity will be conducted down that rod through wires and into the ground. And that's what we call grounded, because the ground then absorbs that electric charge. That way it keeps the building from catching on fire or from possibly exploding. All right, so this will take care of the first whole front page of your guided notes, and I'm going to put this on YouTube as Chapter 14, Electric Charge and Static Electricity. So I'll see you next time very soon.